All right, so welcome back to our channel. We're going to be doing some math today. We are in 3.4 and we're still talking about Allie and Dane's pool. The next question that we're going to answer is this one. Write the equation for that represents Allie's pool, like the draining of it. And at first I was like, wait, I'm lost. I don't understand. I feel like I'm missing information because they didn't give us any information about Allie's her slope or her y-intercept. But if you look really carefully, and if you have young eyes, not like mine, right, you see that we have these tiny little tick marks here. We already know this one is at 24. So let's count. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if 12 of them make 24, very good, very good. Someone already wrote it. That means we need to write this right here as 20. So here we go. Let me just do this really quick. This is going to be 20. Okay, so if that's 20, that kind of helps me. And then I look up here on this side, and I don't really see tick marks on this side. The only thing I see on this side is that this is 24,000. So the other piece of information I'm going to have to tell you is that this number is 28,000. So I think I forgot to give that to you. So now you know that this is 28,000. Everybody okay with that? So this right here is 28,000. Everybody okay with that? Shelton, were we supposed to know that on our own? I don't think so. So somehow in the problem, I should have given you more information and I neglected that. So maybe that's the reason why you guys didn't answer that question last night. So there we go. Okay, so the next thing that I need to do is I need to, let's see, what did they tell me to do? Write the equation that represents the draining of Allie's pool. State the domain and the range of the function for a of x. So because I'm going to skip equation right now, I'm going to go with domain and range. What's the domain of this function? So ignore this blue function for now. Look at this, is that reddish line right here? Look at Allie's. What is the domain? What is the domain? So domain. How do I look for a domain? What's the domain for a of x? Someone said the domain is from 0 to 20. Now, I'm just going to say, for your quiz that I just graded, a lot of you don't know what domain is. So when you're looking for domain, this is what you're looking for. From left to right. Okay, you're looking at the smallest x value to the largest. Okay, so let's do this one together. So looking at this line, the red line, what's the smallest x that you can get? What's the smallest x that you can get? Yeah, it's 0. How do you know, Miss Johnson? Because look, there's no part of the graph over here. Right? There's no part of the graph over here. There's nothing. Right? And then so we have 0, and then we start moving to the right, and we want to look for the largest. And you're like, oh, it's 20. Okay, now here's the second part. I did not mark you wrong if you put parentheses when you should have used brackets or vice versa. So if you use parentheses, you would have been wrong. This person used brackets because 0 is included and so is 20. Ms. Johnson, how do you know that 20 is included? Because there's not an open circle at 20. There's not an open circle. What is an open circle, Ms. Johnson? Looks like this, right? Like this, right? Do you guys remember this? Graphing this on a number line, right? You would open the circle. It's empty. Okay, so that's my domain. What is my range? Okay, so let's go range. Look at your range. So here, instead of looking from left to right, what are we doing? From what? No, the other way, from bottom to top. Very good. From bottom to top. So we look at the smallest x value or y value? Yeah, smallest Y value to the largest. Doesn't that make sense though? These two things are saying the same thing. Bottom would be the smallest Y. Top would be the largest Y, right? Okay, so you're looking from the bottom. What's the lowest Y you can? Now, this is where people messed up. They wrote this is wrong. This is wrong. People wrote their range like this. They said, oh, it goes from 20, 0, and then they put parentheses on this like this, to, and then they put 0, 28, oops, 28,000. This is the way they wrote their range. This is not a range. This is not a range. This, for me, when I look at this, I'm like, oh my gosh, they just said, what could they have said? That the days of the week go like this: Sunday, Wednesday, Tuesday, Thursday. Do you see how wrong that sounds? Like, it made me think, like, I couldn't even say those dates in order. Like, or if you're counting and they're like 1, 7, 8, 4, 3, right? Okay. So, or if someone's singing the ABCs, they're like L, P, T, S, Q, R, V, like wrong. Oh my gosh, how cute. Okay, so does everybody see why this is wrong? Ms. Johnson, why is this wrong? Because you're only supposed to care about the which values? Yeah. So which one's the Y here? 20 or 0? 20 or 0? 0. So you want me to erase 20? Yes. Okay, which one's the Y? 0 or 28,000? Yeah. So you want me to erase the 0? Yeah. Boop, boop, boop. And then I'm going to put brackets. Ms. Johnson, why are you putting brackets? Because there's no open circle. So do we feel better about this range and this domain? That's one of the biggest mistakes you guys made on yesterday's quiz. I was like, and it makes sense. I'm just going to be honest with you. Domain and range is a challenge for students. I'm still teaching it a lot in my integrated 1, 2, and 3 classes, in all my classes. Why, Ms. Johnson? Because it's just like one of those things. I'm just going to put this over here for now because I can't fit it over there. Okay, now we got to write the equation. So you have two options. Do you like slope intercept or point slope? I'm making this smaller. Do you want this? Look at your red. Do you want slope intercept or point slope? Slope intercept or point slope? Yeah, it actually doesn't matter. All of you are like point slope. I personally like point slope, but for some reason, because you guys have been working with slope intercept longer, that tends to be my students' favorite. But if you think about it, point slope works with every point and slope that you're given. Slope intercept only works if you're actually given the intercept. In this case, we were given the intercept, so you can use it. Okay. Let's see. They actually didn't give us the slope in this case, so we'd actually have to find the slope. How do we find the slope here? How do we find the slope? Yeah, it's rise over run. Very good. Or some people say the change in Y over the change in X. So I always start with the bottom point down here. And I draw like this. How much do I have to go up on an elevator? Like if I took an elevator all the way up, how much would I have to go all the way up on the elevator? When would I stop? How much is this rise? How much is this rise? How much did I start? I started at 0 and I went all the way up. How many floors did I go up? Yeah, not 24,000. I need to get to the red, not to the blue. Yeah, very good. So you want me to put 28,000 there, Ms. Johnson? Yep. So I put 28,000 as my rise. meaning that's how many like floors I had to go on the elevator, right? Imagine pushing a button that says 28,000. I would not. No, thank you. I would not get on the elevator. Would any of you do that? Would you guys get up there? I wouldn't. Sorry. Okay, sorry. I need to focus. Okay, then I'm gonna go left. I'm gonna run. When you run, you guys are running. I don't know about you. I can't run up and down a building. I know some of you are like Spider-Man. Oh, that's not a very good triangle. Pretend this is a really good right triangle. It's okay, but it needs to be better. How much did I go left? How much did I go left this way? Me too. Yeah, but that 20, if we're being really specific, I'm so glad you guys fell into my trap. It's not a 20. Anybody know what it should be? It's not a 20. I know. I love when you guys get wrong stuff in class, because then you're going to get it right. Yes, very good. Someone's like, -20, Miss Johnson. Exactly. Bam. Bam. Miss Johnson, why is it negative? Because you went left. Because I went left, that means it's negative. So for those of you who wrote 20, technically you're wrong, but I understand why you put it. So if you got it wrong, I want you to get it right during the quiz. Tell yourself right now why it has to be negative. So I know this sounds really funny and it's going to sound like you're talking to yourself. I sound like I'm talking to myself all the time, but that's okay. So you should tell yourself why this is -20. I'm going to give you 5 seconds. Why is this negative? Okay. Some people talked about the actual slope of the line and they said, Ms. Johnson, this whole slope is negative because we're going down, down, down the hill. Yes. Other people said because we went to the left. Because we went to the left. And in math, left means negative. Does that make sense? Very good. So either one of those explanations is right. For those of you who knew that it was going to be negative, you probably will do something. I do the same thing. I say, I don't know, but my slope is going to be a negative number. And I put m equals and I put a negative there to remind myself it's going to be negative. And if I mess up on this, I caught myself with this, right? Okay, so then I put a -20 here and then I divide. I think that's -1400. That looks right, right? You guys agree with me on that? Did I do that right? Okay, very good. So there's my slope. For those of you who like slope intercept, here's slope, here's intercept, you're done. For those of you who like point slope, you get to choose. Do you like this point or do you like this point? I like this point because it's smaller numbers, just saying. But because they gave me the intercept, I'm probably going to write my equation with slope intercept. So that's y equals to mx plus b. So y equals negative 1400 x plus 28,000. So I'm going to copy all this work and put it down there. Oops. Wow. I exploded. My face exploded, y'all. You're welcome. Oh no, it's going to come again. Wow. There you go. That's how Mrs. Johnson sounds when she sneezes. I know you guys were wondering, like, I wonder what she sounds like. No, I know. We're just kidding. Okay, so there's your equation. Oh no, I forgot a 0. How did that happen? Oh, I didn't clip it all. That's okay. I'll write them in. All right. So let me fix answer. Okay. So if you're really trying to get good at this, really, really good at this, I should be able to point to this number and be like, why is it -1,400? Why is it 28,000? You should be able to explain. 28,000 is what? What does 28,000 mean in terms of Allie? What does 28,000 mean in terms of Allie? Nope, it is not the range. This number, what does 28,000 mean? Remember, if you're going to tell me range, you've got to give me a from and to. That's like you say, if you said 28,000 is the range, that's like hey, Miss Johnson, when are you going to be tutoring? And I'm like, 28,000. Usually when you ask a when, like how long are you going to be tutoring? You say from something to something, right? Yeah, it's how much water there was in her pool in the very beginning before she started draining her pool, right? Or you can think about it as how much water she needs to get rid of. Okay. Physically, it is the intercept, but I was more looking for the context of the problem. So what does this number mean in terms of our context? What does negative 1,400 mean? Yeah, it's our slope, but in terms of our context, what does that mean? In terms of our context, what does that mean? Yeah, it sounds really weird, but it's how fast our water is draining. How fast our water is draining. So at 0 minutes, there's 28,000 gallons of water in Allie's pool. The next minute, she has 1,400 gallons less. The next minute, she has another 1,400 down and another and another. So if they were racing, you can see that Allie's pump is faster or slower than Dane's. Is Allie's pump faster or slower than Dane's? Is Allie's pump faster or slower? Yeah, it's faster. See, that's what you guys said earlier. It's steeper. But Dane starts with less, and you would assume that he would have been done first, right? Yeah. Losing water that fast. Yeah, they're using pumps for sure. They're not just like unplugging the tub, right? All right, let's continue. It says when, oh, let me do this over here because then I can show you a little bit better. No, here, my bad. So we answered this. No, yes, here. So when is a of x equal to d of x? When is a of x equal to d of x? When is a of x equal to d of x? Can you guys look at that? What are they talking about? When is a of x equal to d of x? I'm going to move some of this stuff. I'll just leave it. When is a of x equal to d of x? Yeah, it says it's not intersect with the C. Yeah, at their intersection point right here. But what does that mean? In the context, what does that mean? So make sure you're writing that answer down because I'm not writing it down. Here is where a of x equals d of x. What does that mean? In the context, what does that mean? What does it mean? Like in terms of Dane and Allie, were they cross paths? Kind of. But think about what's happening. So Allie and Dane each have a pool of water that they're draining, right? And Allie's pool has more water and Dane's pool has less. And then at this point, they intersect. What does that mean? Yeah, it means the water levels are the same. So if they were racing, if this was a race, this is when Allie's and Dane are at the same exact point in the race. Got it? At the same time, they're at the same time and the same place. At the same time and the same place. Got it? Okay, next question says, what does this mean? Do you guys all know what to write here? Do you guys get what to write? Here, I'm going to snip someone's answer because that was a good one. There's actually several answers that were really good. So here, so make sure you have this down. I don't really care about it being on your paper. I really care about it being in your head. So technically it means that the water levels are at the same place, and I'll put same place and same time. Right? So find a of 5. What does that mean? What is a of 5? So over here, A of 5 is, okay, this is A of 5 here. What would I do to find A of 5? Everyone say this, say A of 5. Did you say it? Good. Do not say A times 5. That's not correct. A of 5 means, do you guys see what, oh, you didn't put it in the public chat. Hey, Noah, can you put that in the public chat? What does A of 5 mean? Thank you. So literally it means when X is 5, that's what Noah wrote. So we're going to write that. So literally it means when X is equal to 5. Let's make that smaller, right? Arg. No, there it goes. So, but what does it mean in terms of the context? What does it mean in terms of the context? Yeah, it means, oh no, you're not going to let me type. Oh my gosh, someone else put it. I don't even have to do it. Yay. Yay for you. Yay for you not making me type because my OneNote is not listening. Yeah, it actually means how much water is there after 5 or at 5 minutes, not after. Very good. So essentially what you're doing is you're plugging in 5 to here. Can you guys all do that really quick? Plug in 5 right there. I'm gonna give you a couple seconds to do that. Use a calculator if you'd like. Actually do it too, because some of you, I need you to practice doing this. The only way that you're gonna get better at this is if you practice it. So right now I'm just doing a little random commercial. So like, for example, how did you get better at blank? Think about something that you're good at, right? How did you get better at that? Right? How did you get better at that? Right? So I will talk about softball. How did I get better at softball? Playing, making a bunch of mistakes, right? All good. All right. So I'm going to use my calculator, my best friend, Desmos to the rescue. Okay. So I'm going to plug in 5 for here. Okay. So I'm actually going to write it. I'm going to write it out here so that you guys can all see. So A of 5 equals to negative 1,400 times 5 plus 28,000, right? I want to snip this. There you go. And then, so I want to know what that is. So I'm just going to copy this part here. So for those of you who are like, I don't know if I want to use a calculator, use a calculator. Use a calculator. Why would you not? Okay, let me copy this right here. Ms. Johnson, why don't you just write that down? Because I want to show you that you can use a calculator too. Ain't no shame in using a calculator. Actually, I'd prefer you to use a calculator, right? Use the calculator. Very good. Someone actually wrote it the way I want you to say it. So please repeat after me. Say A of 5. A of 5 equals to 21,000. So what does this mean? So according to this person, it says the water level at 5 minutes is 21,000 gallons. Everybody okay with that? Another way to write this is this. This is what you guys are more used to. Oops, I shouldn't put a column there. So another way to write this is using it as a point. So 5 comma 21,000. This is the new way that I want you guys to get used to seeing. Things that I've seen wrong is people like writing this and they're like, oh, I got to divide by 5. No, that's only true if it says A times 5. Does this say A times 5, my people? Does this say A times 5? Does this say A times 5? No, everyone say A of 5. A of 5. So I want to know this, like in regular terms. Why aren't you letting me like type today? Big meanie. Okay, so I'm going to type this out somewhere else and then, oh, I know how to do this. Hold on, give me a new window. Okay, I'm gonna, oh yeah, it's right there. Sorry, let me find us. There it goes. So another way to say this is when, so A of 5 means what is your y coordinate when x is 5? That's what it's asking. So don't think it, please hear me on this, because this is, someone's going to do this wrong on the quiz and it's going to be like, I wish you listened. And I saw some of you not listening on this last quiz because you did stuff that I was like, I wish you'd listen. So A of 5 means this. It does not mean A times 5. It does not mean A times 5. Okay. If you know how to look at this, then the thing that I'm teaching right now in integrated 2, you're going to be good at, because there's very similar things. Same with in integrated 3. Okay. Okay. So D of X equals 2000. What do you think D of X equals to 2000 means? What do you think this means? What do you think this means? D of X equals 2000. If A of 5 means what's your Y when X is 5, what do you think this means? Anybody? Yeah, very good. We need to find the value of X when Y is what? Very good. So I'm going to write this over here, kind of squish it in. So I'm going to write D of X equals 2000 means what is your Y or what is your X? What is your X? Good. When X, no, when Y is 2000. Got it? So how would I do this one? So here I just plugged in. So first of all, you have to find D of X. Where's D of X? No, this is A of X. Where's D of X? Oh, here's D of X. Ms. Johnson didn't label it as D of X, but this is D of X right here. You guys all see this? Either this one or this one, whichever one you want to use. So I'm going to copy, I'm going to use this last one. See if I can grab it. Yeah. Okay. And I'm going to put it down here. Okay, let's see. So here's D of X is this. So if D of X is this, yeah, they want you to set this whole thing equal to 2000. Very good. Set this whole thing equal to 2000. And then what do they want you to do? What do they want you to do? It says, what is your X? Oh, they want me to solve for X. Can you guys all solve for X right now? I'm going to give you a second. Go ahead and solve for X. Okay, just as a reminder, if you're not actually doing this work, you're going to make it harder for yourself on that next quiz. Okay, so I'm going to show you how to do this. And you're going to be like, oh yeah, that makes sense. Of course it makes sense. I'm the one doing it. I'm the one doing the thinking. So please make sure that you know how to do this. If you're just watching me do it, that's not the best. Okay. All right. What's the first step in terms of solving this equation? What's the first step in terms of solving this equation? For those of you who don't know, it's SADMEP. SADMEP. If you recognize SADMEP, it's really PEMDAS backwards. And then, so what you're doing is you're going backwards and you're saying, is there any subtraction or addition? And so the answer is there any subtraction or addition on the X side? And the answer is yes. So how do you get rid of plus 24,000? You subtract 24,000, right? So then this is negative 22,000 equals to negative 1,000x. Okay, so I did subtraction and addition. The next thing I want to try, is there division and multiplication on the X side? Yes. So how do you get rid of what's happening? Well, Ms. Johnson, there's an invisible time sign there. So I need to divide because that's how you undo multiply. So you undo it by dividing by negative 1,000. So X is equal to 22. So X is equal to 22. So I'm going to write that over here in my answer. What does that mean? What does this mean? What does d of X equals to 2,000 when X is equal to 22? What does that actually mean? What does that mean? Well, it says when your water level is 2,000 gallons, when you have 2,000 gallons in the pool for Dane, it took 22 minutes to get to that point. It took 22 minutes to only have 2,000 gallons in the pool. Okay. This looks crazy, but please just think about this as a number. When is this number bigger than this number? When is A of X bigger than D of X? Okay, what? Look up here. When is A of X bigger than D of X? When? When is A of X bigger than D of X? When is A of X bigger than D of X? So really quickly, are we talking about X's or Y's here? When is A of X? So this is a question. Nope, we are not talking about X's. These are not X's. Whenever you see A of X, F of X, T of X, L of X, M of X, whatever, these are all talking about Y's. Sorry. These are talking about Y's. So when is Allie's Y bigger than Dane's Y? Okay, when is Allie's Y bigger than Dane's Y? Yeah, someone said at the start, Ms. Johnson. Oh, okay. Just at the start? Just at the start? Someone says no. All the way till when? All the way till when? Very good. In this whole area is when A of X is bigger. So what does it mean when A of X is bigger than D of X in the context, in terms of the pool, in terms of the water, in terms of time? What does this actually mean? What are they asking for? When does Allie's pool have more water than Dane's pool? When is Allie's pool have more water than Dane's pool? So for those of you who said at the start, that's exactly right. So if we knew this value here, which we do, it looks like it's, I don't know, let's see, what value would this be right here? What number would this be when they're equal? Anybody know? What number is this right here? What number would I write right here? You said until they intersect. What number is that? Yeah, what number is that right there? You guys can figure this out. Come on. Yeah, very good. Very good. 10. Someone said 10. Where the heck did they get 10 from? That's their favorite number. No. Where'd they get 10 from? Your brain has to know this, not their brain. I'm glad their brain got it. But why? Yeah, the tick marks. Very good. Earlier, someone said the tick marks, each one counts for 2. So 2, 4, 6, 8, 10. So at 10 minutes exactly is when they're equal. So when is A of X bigger than D of X? When? So someone said to this from the start to their intersection points. Ah, man, I wish there was a very quick mathematical way of writing that. Man, I wish there was a quick mathematical way of writing that. Dang, that'd be so great right now. If there was a quick mathematical way of writing that. You all know this. How do you write that? Yeah, someone wrote it. Someone wrote it. Don't believe him though. Don't believe him. Figure it out for yourself. Does that answer make sense? Does that answer actually make sense? You guys can't, right? You can't depend on this person who wrote this answer, because that would be called cheating during a quiz. Why does this answer make sense? Oh, because someone said in the start, all the way to the intersection. Technically, I would put a parenthesis around the 10. But remember, Miss Johnson's not going to be picky about this because this is you guys learning how to do this for the very first time, right? This is like when you're first learning how to write your letters. And I'm sure you guys did this. Like you wrote your E backwards, right? You wrote your E backwards. No one like sat you down in kindergarten and said, hey, look, that's wrong. No, your teacher just said, hey, you got to practice your E's more. So technically it is, you are, how do I put this? Allie's is not winning. Or I don't know. I guess that would be losing. But Allie's number of gallons is not bigger than Dane's gallons at 10. So technically I would write this as a parenthesis over here. But guess what? If you put that, I'm going to be so excited that it's right. So you're fine. All right, moving on. Let's see. Okay, this month, Allie and Dane decided to work together by putting both pumps in the pool at the same time. G of X equals to A of X plus D of X. Like, wait, what? So instead of their each pump working on its own, they decided to combine the pumps and allow the pumps to work together. Does that make sense? Now think about this. Think about it. If you have both pumps working together, number one, they'd have to have, how many gallons are both of those pumps working on right now together? How many gallons are both of those pumps supposed to get out of both of those pools? Do you guys get it? Kind of. No, in the very beginning. So, okay, let me start this all over again. They decide, instead of working separately, Allie and Dane are going to work together. Allie's pump, Dane's pump. They're going to work together. Does that make sense? Everybody okay with that? Okay. So if Allie and Dane work together, yeah, how many gallons are they? Yes, it's going to be this plus this, right? This plus this, which I think is 52,000. 52,000, right? Yeah, so, them working together is going to be all the way up here. I need to erase some of this stuff, so sorry. If you need this, it's still going to be on the video, but right now I need it off. Sorry, I need to erase this so it's a little bit cleaner. So here, so it's going to be at 52,000. Everybody okay? Yeah, 52,000. Ms. Johnson, where'd you get 52,000? I combined both of their gallons together, right? So up here, this is where they're, I don't know, somewhere here, right? So 52,000 is how much they're going to start with. Okay. Everybody good on 52,000? Okay, so if I actually just write out A of X plus, where is it? A of X plus D of X, right? It would just be me adding those two equations together. So when they wrote their equation, Allie and Dane decided that they would only model time when the pumps were in the pool, so they didn't have to worry about the short time that it took to move the pumps from one pool to the next. What does G of X represent? G of X represents both pumps working together on both pools. Does that make sense? So A of X before represented Allie's pump working on Allie's pool. D of X represented Dane's pump working on Dane's pool. So it says graph on the same axis, a of x plus d of x. So what does this mean, Ms. Johnson? You want me to take both of those and add them together? Exactly. That's what it says to do. Do you guys all see how it says add that together? Yes, everybody see that? So this is the first time you guys have actually ever added two functions together, but you've done it before, but we've never said, oh, add these two functions together. So I'm going to take a of x, which is this guy right here without the 5. I'm going to take my a of x. Wait, hold on a second. Where is it? Here it is. So a of x is going to be, so g of x equals to a of x plus d of x. So a of x is equal to negative 1400 x plus 28,000. Plus d of x is this guy over here. Negative 1,000x plus 24,000. Okay, there's my equations. Everybody good? Let's make it a tiny bit bigger. Okay, so there's your g of x. Looks kind of crazy. Can we clean this guy up a little? Does anybody see anything that I could do to make this look a little bit cleaner? Anybody see anything that I could do? Anybody see anything that I can actually do? Yeah, add the numbers. 28,000 plus 24,000, you guys already calculated was 52,000. Perfect. Anybody see anything else you can add? Yeah, the x's. Negative 1,400x plus negative 1,000x is negative 2,400x. So this represents a whole lot of water and a whole lot of draining rate at the same time. Is everybody comfortable with this? Good. Can I ask you a question? What do you guys think? Do you think it's going to finish slower, faster, or in between? Slower, faster, or in between? Can we just get a gut guess here? Can you just get a gut guess? I think it's going to be this. Yeah, it's in between. Because you guys have done this before, right? Like, what can I think about? I don't know. For some reason I'm thinking I'm thinking about cleaning. Like the rate at which I clean plus the rate at which my daughter cleans, right? Is the rate that we clean together is going to be in between our two rates. Because my rate is going to go slower, right? I clean faster. I've been cleaning longer, right? So that makes sense. And then the rate at which she cleans is going to be, and then if we combine those two, it's going to be somewhere in between, right? That makes sense. Sometimes it's actually going to be, it depends. Yeah, I'll just be quiet there. So 52,000 gallons. When is the pool going to be completely drained? Because I want to know where it hits here. I want to know when it hits like here. Yeah. Okay. So I'm gonna find that out. So you can find this out by either solving for 0 or doing whatever. I'm actually going to graph this on my Desmos. Where's Desmos? Here you are. So let's see. Let's put this as X. And then what's the other one? Negative 1,000 X plus 24,000. And then the last one is negative 24. Oops, 20. X plus 52,000. See, did I do it right, guys? Negative 1,400 X plus 28,000, negative 1,000 X. What's this? 20. Okay, good. I did it right. You guys are like Ms. Johnson. It didn't graph it. Anybody know where I should look for my? Where are the lines going to be? Where should Ms. Johnson? You broke Desmos. Someone say no, Ms. Johnson. Yeah, you got to go way out. Why do you got to go way out? Because these numbers here are way bigger than these numbers here. So I'm going to zoom out a lot. Oh, there they are, Ms. Johnson. And they look, Ms. Johnson, they look like straight lines again. Yeah, that's because of the X. So let's make our Y's, this X, let's make our Y's like -1 to like, what was that? Like 24? And then let's make, not 24. our y's would be 52,000. Okay. And then let's make our x's from -1. And I think it was like 24. Yeah, that looks pretty good. Are you guys right? So here's, I think this must be Dane. Green is Dane. This blue is Allie. And this guy right here, that is us working together. And you guys were right. It's in between. Good job. It is big. I agree. All right, I need to finish. Okay, so we did that. Done. Oh, shoot. They gave us a thing. Okay, that's okay. So write the equation for the function g of x using the graph you created. We did that. Compare this equation to the algebraic representation. We did that. Should the algebraic equation g of x be the same as the function when you graphed it? The answer is yes. I'm just going to skip here really quick. Okay. So let's practice this really quick. Use the graph context to answer all of these questions. Okay, so I'm going to go here and I'm going to go here. So this is going to be the last part of today. So what's the domain of the purple function? Let's turn this guy off and look at this guy. What is the domain? I don't need this, right? Nope. What is the domain of this function? What's the domain? Again, this is another opportunity for you to practice domain. What is domain? And there's that number in case you were wondering. Yeah, I thought it was going to be 22 too. Actually, I think it is supposed to be 22. Hold on a second. Did I mess up? Hold, please. No, I did not mess up. It's good. I thought it was going to be 22 too. I thought it was going to be in between. I understand why you put that. That's awesome. Me and you were thinking the same. So yeah, so the answer is from 0, looking left, the smallest is 0 and the biggest is 22. Some of you are like, Ms. Johnson, but I see stuff over here, but that's just graphing the line and not the actual context. So yeah, it goes from 0 to 21.667. What does that mean though? What does it mean? What does it mean? So it actually means that it took 21.667 minutes to drain both of the pools with both pumps. Does that make sense? Okay, I think I'm going to pause here. I'm going to have you guys fill this in as best as you can. And then that's pretty much it. Let me pause our video really quick. So really